Dear friends, so in this video we are going to discuss about waste heat recovery or residual heat recovery, which is the important component of thermal sciences in mechanical engineering field, where most of the energy is unutilized or is going as waste. How we can recover those heat which is going as waste, that is the important challenge we have. So in this video we are going to discuss the basic principles about what is waste heat recovery. In the next video, we will be discussing about various types of waste heat recovery systems. Okay. So residual heat recovery or waste heat recovery is a way of uh, bringing out the sources of waste heat for useful work. It can be used in the process industries, heat industries, and many applications it has. Those things also we are going to discuss. So it is a byproduct. Actually, we can call this as a byproduct of power generation or process heat or waste heat. It may be heat or cold. So where we have the waste heats like flue gases or exhaust gas from the furnace or gas engines or IC engines, and thermal post combustion, that is after combustion some heat recovery will be there, and exhaust air or hot air, pressurized hot water, and steam or exhaust vapor. These are the typical examples of waste heats. Where we can have the application of this residual heat or waste heat. Preheating, in the case of in ice engines also we can recover some waste exhaust gas and we can utilize that exhaust gas to preheat the incoming air. That is one type. In boiler also we can have the feed water heating, that is economizer, by recovering heat from the flue gases which is coming out from the boiler furnace, which is going as waste to the atmosphere. So by the same time we can save the environment also. Atmosphere can also be saved by utilizing the exhaust waste heat which is coming out from many sources. So by there are two advantages. Main advantage is we recover the heat and safeguarding the environment or atmosphere. And load preheating. Power generation also we are having the application of this heat recovery. Steam generation, power plants, process steam, textile industries, sugar industries. In many places we have the steam generation. Those places the heat is going as waste. Those waste heat can be used for many other applications. And for cold storage also we can have this type of heating. And space heating, in winter we can have the space heating application. Transfer to liquid or gaseous process steams. So these are the major applications of residual heat. How, by thermodynamically, how we can say that how the heat can be recovered? This is known formula according to the first of thermodynamics. Everyone knows this. Q equal to mCp del T. Cp is a constant pressure, specific heat at constant pressure. Heat, Q, capital Q is the heat. Mass flow rate is small m. Flow rate of substance in meter cube per hour or meter cube per second, that we can convert. Density, rho is a density, kilogram per meter cube. For flue gases it is 1.19. For specific heat Cp for hot flue gases is 0.24. So for example, if you take one industrial application, in a heat furnace the exhaust gas leaves the furnace at 900 degrees Celsius at the rate of 2100 meter cube per hour. The total recoverable heat from the exhaust gas at 180 degree can be calculated. How? We are going to calculate using the above equation. Q equal to mCp del T. The temperature difference is given 900 and 180 degree, that can be del T. And the flow rate is given as meter cube per hour, that is capital V is given. And in the further equation we can easily solve this. Q equal to 2100, that is mass flow. M equal to rho into V. Rho is 1.19. V equal to 2100, that is M. In the mCp del T formula, M we can easily calculate by rho V, multiply rho into V. So M we have calculated. Cp is given 0.24 for hot flue gases. So kilocalorie, in terms of kilocalorie we are going to have 431,827, 4,31,827. If you divide by 4.32, we can get in close joule per hour. By 3,600, if you divide by 3,600, we will be getting in close joule per second. By installing the recuperator or heat recovery channel or heat generator or heat exchanger, heat can be recovered to preheat the combustion air. The fuel savings by means of this system is 33% for 1% fuel reduction for every 22 degree centigrade or Celsius reduction in temperature of flue gas. So conventional, the waste heat does not influence the industrial process, but it helps to generate additional power of the same power plant. Waste heat can be recovered by the following ways. Conventional steam power plant use Rankine cycle, organic Rankine cycle, ammonia water systems, and thermoelectric power generation. So in the next video, we are going to discuss about these 4 various systems, how we can recover the heat. So this is a short video. We have been discussing about the basic principles of waste heat recovery or residual heat recovery. Thank you for and in this video, that is the second conventional steam power plant using Rankine cycle. This is the most common generation of power generation heat recovery, and how the Rankine cycle is working. This is the layout. So this is called waste heat recovery system. HRSG means waste heat recovery system, and it goes to the plant use or export steam. Here the steam turbine for electricity power generation. This is for steam turbine. This is for export of steam. And as usual, we have the condenser and cooling tower. And here we have the condensate treatment. Here from the furnace, we are getting the heat recovery. This is a heat. This is the first stage. From here, we are getting the heat recovery. Okay. This is a residual Rankine cycle in a simplified diagram. The exhaust heat recovery boiler, it goes to the turbine and it comes to the condenser and pump. This is a normal, typical steam power cycle. Thank you for watching this short video. Thank you.